Hello everybody and welcome to Investigation 2.3. In this investigation we're going to be interpreting graphs of exponential functions. So we're going to be looking at how graphs, how we can decode them, to find exponential functions, find their equations, be able to find the growth factor, the y-intercept and that sort of thing. So we're going to decode a bit. So our focus question, which you do not need to write down, is how is the growth factor and the initial population for an exponential function represented in a graph that represents the function? So let's take this and roll with it. We have a situation here. I looked up on the internet and found out that rabbits have what's called a gestation period of 30 days. That means every 30 days they can have babies. And based on that, rabbit populations can essentially grow out of control very quickly. And there's actually some islands in the Pacific who have issues with that, or the islands have issues with that and that sort of thing. So rabbits, they can have babies every 30 days, and their populations can quickly grow out of control. Using this graph that I've created, find the answers to the following questions based on their exponential growth. So let's do just that. Let's do a little bit of work. Here are our questions. Growth of the bunny population. First, I'm just going to look at this graph. And when I look at this graph, I want to find locations where I know where there's clear point values that I can find and create. And if I look at this, I can see that I have a clear point value right here. There's a clear intersection right here, and this kind of is clear and that is not so much. But I can see based on the months, or based on every 30 to 31 days, that the bunnies are mating and they are growing in population. So first of all, we need to find the bunny populations for 2, 3, and 4 months. So when I hear this, when I get any question like this, I'm going to instantly make myself a table. So I'm going to put months here, and I am going to put P for population. I'm going to extend this a little bit. So months, they want to know 2, 3, and 4 months. Let's look at the information here. Since we have a clear view of 2 months, it looks like at 2 months we have 16 bunnies on our hands. Cool. 16 bunnies. At 3 months, again, a clear location. So I'm going to go up to 3 and then go over on my y-axis, and I have 32 bunnies. My next one, I'm going to go up to 4 and move over, and I get 64 bunnies. So I can now analyze this table to figure out maybe my growth factor and potentially a couple other points. So our next question that we have here is we need to use our answers for the table for 2, 3, and 4 months and estimate the population for 1 month. So when I look at my months, I'm seeing that they're increasing by 1, so it's a +1 sort of thing. But over on my y-axis for the population growth, 16 to 32 and 32 to 64, there's not a clear constant addition, but we can say there's a constant multiplication of 2. And that's important. That constant multiplication of 2 is telling me that is my growth factor, which hopefully you guys are all screaming in your heads because I've been beating this into you. So we're going to look at 1 month. So essentially we are going down back in time a little bit. We're subtracting 1. If we're going to subtract 1, we need to go back in time also for the bunnies. And instead of multiplying by 2, we are going to divide by 2. So I'm moving that graph back, or I'm moving my table backwards. If I were to divide 16 by 2, I would get 8. So at 1 month, we have 8 bunnies. How exciting. There's 8 little bunnies running around. And they're nibbling on things and eating bunny food, and it's exciting. Now, we have to explain how we can find the y-intercept of this graph. We need to find this point, which is not incredibly clear. Y-intercept is essentially moving back in time one more month, so that way we get an x value of 0. So the y-intercept, that means x is equal to 0, and then we're figuring out a y value. So if we're moving back in time, we are subtracting 1 for our months. That means we are also following our growth factor back in time, and we're dividing by 2 again. And 8 divided by 2 gets us 4 every time. 8 divided by 2 gets us 4. And this 2 is our growth factor. It's not coming out of thin air. So essentially, we are starting out the y-intercept, the very first notice of all of these bunnies, we started out with 4 bunnies. Probably 2 males and 2 females, and then they procreated, and it was exciting. So we have little bunny families running around all over the place for generations and generations, every 30 days. So now let's do just a little bit more math. We have our bunny population still, and we can still see the graph. We need to explain how we can use the graph to find the growth factor of this population. So how can we use this graph? Well, one way, what's really nice, is they kind of led us to doing this. Through this question up here of what happens every 2, 3, and 4 months, we were able to create a table. So we could simply say, I made a table of points I could find. And then from there, I was able to see the difference. Then I could see the multiplicative difference. Wow, I can't spell. Really can't spell. So essentially, I'm able to see, and if I were to just simply look at my y-axis, let's look at this y-axis, I could see this jump from 16 up to 32, and then up to 64. And I could even predict further. What do I believe is going to happen in the following month? If our pattern was times 2 to get from 16 to 32, and then from 32 to 64, I had to multiply by 2 again. That means I would have to multiply 2 yet again, and my next number, my next y-intercept would probably be 128, because 64 times 2 gets me 128. So I can use my graph in that way. I can pay attention to the y-axis and how things are changing vertically. Now let's go on to the next part. It says write an equation for the population P in months M. So let's go back to our exponential value equation. We had y is equal to a times b raised to the x power. We know y and x are our outputs and our inputs. And based on that, we can put in a couple of variables. Well, we know our independent variable in this situation. If we wanted to look at the next month and the next month and the next month, that means our independent variable is m. So our x value is going to be m. That's our months. That's the time that goes by. Oftentimes, time ends up being our independent variable, so keep that also in mind. Our output, y, what do we get out of this equation every single time? Well, we find out what the population of the bunnies are, and that's really exciting. So y, our output is our population, our input is m months. So now we need to figure out what our initial value is, our y-intercept, and we also need to figure out our growth factor. Now, we figured out our growth factor in our very last step, and we also figured out our y-intercept in our last step. And we just talked in the previous question how we can see that doubling happen. And so since we were talking about doubling can be called in math terms a timesing by 2. And so instead of writing growth factor b, I'm going to write 2, because that 2 happens over and over again. And our y-intercept, if we just go back in time and look at our second to last question, and it explains how can you find the y-intercept of the graph, and we actually did that. We said, well, we're going to take our last step. It happened at 1 month. We had 8 bunnies, and we're going to divide that by our growth factor, which is 2, and we're going to get 4 bunnies. So that is our initial population. We started out with 4 bunnies. So we can write our y-intercept of 4 in here. So our final equation is population is equal to the initial value 4, or our y-intercept of 4, times that doubling, that 2, raised to the number of months that we have going on. So, very last question. In how many months is the population going to exceed 1,000 bunnies? So we need to see where it's going to be up above 1,000. We can do this in a few ways. We could extend our table, we could extend our graph, or we could put it into an equation, do a little bit of guess and check. Let's start out by first extending our table. So we have our equation here. We have our table, which is months versus population. And we had, let's just start at 2, 3, and 4 months. At 2 months, we had 16. At 3 months, we had 32 bunnies. And at 4 months, we had 64 bunnies. We can just continue on with our growth factor. Remember, our growth factor is that times 2, each and every time. So every time we increase by month, so increasing by 1 exponent, we are essentially multiplying by 2 because we're adding a 2 to our exponents. We're saying it's 2 to the 5th power instead of 2 to the 4th power, which means we're multiplying by 2. So if I multiply 64 by 2, I get 128. So that's just after 5 months, almost a half a year, we're at 128 bunnies. At 6 months, we are at 256 bunnies. At 7 months, that 256 bunnies become 512 bunnies. And at 8 months, I think we know what's going to happen. I think we're actually going to find our answer, and I think you all know it. We're multiplying by 2 again, so we are going to 1,024 bunnies. So in 8 months, our bunny population, the bunnies, are over 1,000. That's a lot. So now we have over 1,000 bunnies. We actually have 24 more than 1,000 bunnies. Another way that we can check our work is we can put this into our equation. We have P is equal to 4 times 2 raised to the m power, and instead of writing m this time, we're going to put in an 8 in there. So we have 4 times 2 to the 8th power. 2 to the 8th power, if we were to do that. Let me put it in my calculator. 2 raised to the 8th power. 2 raised to the 8th power gets us 256, and we have to do a little bit more math, so we're going to multiply this by 4. 256 times 4. I'm not subtracting 4, so I'm adding 4. Sorry, my calculator can't deal with my fat fingers, and we get 1,024 bunnies. Not enough room. Okay, so I want you to enjoy this concept of graphing and work through the investigation 2.3. Go through the entire investigation A through E, and then after that begin the homework. Thank you so much for listening, and I will talk to you later.